Alright, so this video is on sigma notation and summations. And sigma is this symbol right here, or sum sometimes, but this symbol is a sigma. And it's used a lot in like higher level math. Some of you might see it in like a Calc 3 type of a class in college. It's in a lot of analysis courses, so upper level math. A sigma is like a symbol that tells you to add. A summation is basically all the things with the sigma. And a summation is like an adding machine, right? An adding machine. And I've heard it said that the sigma is an adding machine, and the ultimate adding machine looks like an S. It's the integral. So when you're adding up those bars you might have been doing in the last few days or whatever in calculus class, you'll notice that you're adding a whole bunch of things up to find the area of something, or accumulating something up is possibly another way of looking at it. But you're adding things, and that S kind of represents a summation. So an integral, try to think of that as an S. It's your ultimate adding machine. So we are going to add things up. So you see what all the symbols mean? That's what's stressful about this. More than anything, it's the notation, what everything means. So we can see the sigma indicates that it is a sum. I is the index. A sub I is the ith term. So term like, I don't know, if I is 12, then it's the 12th term. In this case, 1 is the lower bound. For starters, I mean, oftentimes 1 will be the lower bound for your summations. Sometimes it'll be some other whole number. And for this one, it's 1. It does not have to be. And n is your upper bound. It could be a number, or it could actually just be n. So that's what was going on here. So let me just give you the basics of summations. You might remember it, and then we'll kind of talk about how we can go from there. So we have this summation of I equals 1. So what I want to do is I want to plug in 1, and then I want to plug in 2, 3, 4, 5, and 6. So I plug in 1, and the summation is, this is what we're plugging into. It's just 1, right? And now we repeat this process. So we add, and we want to plug in again. Well, now we want to plug in 2. So now we're plugging in 2. So this number is going to keep changing. Now we're going to plug in 3. We're not plugging really into much because it's just I. And we're plugging in until we get to 6, and then we stop plugging in. So I guess this whole thing comes out to 21. This is our upper bound. We stop at 6. So we basically just do this whole formula out for 1, 2, 3, 4, 5, and 6, and then add all of those up. It's a shorter way of writing all the stuff I wrote in blue. So here we go. We start with 0. So if you think about it this way, okay, let me just kind of go from here. I equals 0. I'm just going to show you this. Now don't let this confuse you. I'm just trying to break it down a little bit. So I equals 1, I equals 2, I equals 3, I equals 4, I equals 5. Just so you can kind of see what's going on here. Now we're adding a whole bunch of things up, so I'm just going to put plus signs here. These are kind of like, plus signs. Add, plus, plus, plus. Okay, cool. So when I is equal to 0, we're plugging into here, 0, and we have 0 plus 1, which is 1. When I is equal to 1, we're plugging into here again, so 1 plus 1 is 2. When I is equal to 2, we're plugging into here again. So 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5, 5 plus 1 is 6. So these are the 5 things we're adding up, or I guess 6 things we're adding up in this summation. And we add them all up, so we don't need all of these grid lines and stuff. But again, this summation comes out to 21, I believe. When we look at something like this, it's pretty simple. We start at 3, so we start with 3 squared. And then we add on 4 squared, 5 squared, 6 squared, 7 squared, okay? So I could perhaps give you something like this. I could give you something like this maybe. 2 to the third plus 3 to the third plus 4 to the third plus 5 to the third. And I might ask you to write me the summation of this. So you could perhaps pause the video and try to think about what the summation would be. So you're trying to fill in, I equals something. You're trying to fill in something up here, right? You're trying to fill that in, and you're also trying to fill in this expression. So maybe pause it and give it a try. In about 5 seconds, I will tell you what it is. Okay, so hopefully you tried it, but what it is it's I to the third. It's whatever is down here to the third, and we're starting at 2 and we're ending at 5. So that's what you would do. You could reverse a summation if you look at the pattern that's happening. Okay, last example, and then we might talk a little bit more about some different things, but what I want you to glean from this, and this is a pretty short video, is that the n is treated as a constant in a summation. The n in this situation is going to be treated as a constant. So I want you to pretend it's a constant and pull it right out of the summation, and it's still this summation. Okay, so that's what we want to deal with. Now we don't need to worry about this, so we'll just bring it down 1 over n, okay? And then we're going to work on this problem right here. Well, it's kind of strange. So how would this work? So let's work with this whole black part. What I know is going to happen is going to be 1 squared plus 1. Whoops, that's a 1. Plus 2 squared plus 1 plus 3 squared plus 1, right? And these are the terms. And then all the way until n squared plus 1, right? N squared plus 1. And those are all the terms we're going to be adding up. And that's interesting. And in not so far from now, we're going to be talking about the limit of something like this. So maybe we have a summation that comes out to something like this, n squared plus 3n plus 5 over n squared minus 9. And we're going to be looking at the limit, because once we get that summation, we might have an n in it. We're going to look at the limit as n approaches infinity. So I just wanted you to remember what the limit as n approaches infinity of that problem is. And in this case, the limit as n approaches infinity of that red thing is 1. The limit as n approaches infinity of this is 3. And the limit as n approaches infinity of this is 3/4. The ratio of the leading coefficients. That is like a little bit of foreshadowing, something that's going to be important, but for right now is not important. So hopefully those are the tools you need to do the problems you need tonight. Chances are you're assigned some additional problems with this video. Let me take a look at that, and then we'll wrap this up. Yeah, so for these beginning problems, just consider that you're going to be treating frequently this n on the inside here. You're not going to be dealing with that too much. So that you're going to be just kind of leaving alone. What you do want to plug in for as you're doing these problems is whatever the index of the summation is, the bottom number. So leave the n's be if the summation is going to n, and just try to get an idea of what's going on there. And then you might need a calculator or something to plug in for n equals 10, 100, 1,000. So that's what's happening with these problems. Lastly, I want to talk a little bit about the formulas in this. So if you look in your calculus book, there should be an area where you can find summation formulas. For our course and the textbook I'm using, it's on page 291. So if you look on 291, you'll see a few summations formulas. And let me just kind of show you what those look like. So these are the formulas you'll need to know. You can memorize them or whatever. Some of them make a lot of sense. I can show you where they come from, but I'm keeping this video pretty short so you can get some practice in there. So be aware, like if you were summing something up from, like, let's say it's the summation from I equals 1 to 5 of I squared. Well, that's going to equal, you can just replace this and this with 5 and do that math out. So 5, 6, and then 11 over 6. And literally that will give you your answer. So that will be helpful on these problems. So we will take it from there. We'll stop there. Make sure you do any other problems that are assigned, and I will see you soon. Peace.